My name is Ilmer, and today I'll tell you about parameter identifiability in ordinary differential equations. The problem of parameter identifiability arises when we are dealing with a model for the underlying phenomenon using ordinary differential equations. We might be interested in the identifiability properties of parameters in order to improve the quality of the model. Essentially, we're talking about whether a parameter can be identified in the experiment from the experimental data. And the structural identifiability is a theoretical property that answers exactly that question. There are two types of structural identifiability. There's local, when we can identify a parameter up to finitely many values, and global, when a parameter can be identified uniquely. Multiple existing algorithms solve the problem of identifiability. Some of them rely on power series, others rely on differential algebra. There's also a case when a parameter is neither local nor globally identifiable, which means that it's unidentifiable, and for that we might be interested in things like identifiable combinations. There are also solutions that solve that problem. In this work during the summer, I'm working on converting and bringing a package developed by my colleague Gleb Pagudin and his colleagues called structural identifiability.jl, which solves the identifiability problem using local and global identifiability algorithms, and also extending identifiability property to single and multiple experiment. For local identifiability, the package uses Sedeglavic's algorithm, which essentially builds a power series solution to the ordinary differential equation, and then uses properties of a Jacobian of the output function. And output functions are essentially measurements that can be done in the lab by a scientist. So to answer local identifiability, these steps are used, and the result is guaranteed with a user-specified probability P. Now, the global identifiability problem is solved using a structural identifiability analyzer, which is available for Maple and Julia and was recently posted by us on Maple Cloud and is going to be brought to SciML community. The algorithm converts the input ODE into a system of polynomials and then finds a Grosvenor basis of that system, which by looking at solutions for parameters from the Grosvenor basis, we can answer whether a parameter is globally identifiable. Thank you very much.